In this example, we're told that the mean of a population is 450, that the distribution of sample statistics has a standard deviation of 8. Notice that that means the standard error is 8. And that we have gone out, collected a sample, and we have an observed statistic of 456.2. I will note that the 450 is the population mean, so its symbol is mu. I will also note that the observed statistic is 456.2, which is a sample mean, and so it is called X bar. Part A asks us to create and label that distribution of sample statistics. We're going to label that horizontal. I'm going to do part A and B together, where we label the horizontal axis of our distribution of sample statistics with the values of the sample means and also with the values of the standardized statistics, the t-scores. All right, here we go. So I have a mound-shaped distribution where the values in that distribution represent simulated sample statistics, simulated X-bars. This is a distribution of sample statistics. And in this case, since we're talking about quantitative data where our sample statistics are actually sample means, another way we could describe it is a distribution of sample means. What this means is that there is a population that has a population mean of 450, and we went out and collected samples from that population, and these are the sample means from each of those individual samples that each have the same sample size. We notice that the distribution of sample statistics has a standard error of 8, meaning the distance between each of these vertical lines is 8 units. So the center of the distribution is 450, which is the population mean. And then if you increase 8 units, you're up to 458. Increase another 8 units, you're up to 466. If you start at the middle, which is 450, and go down 8 units, you get to 442. Down another 8 units, you're at 434. So each of these values in red represent sample mean values. Sample statistic values. These are the expected sort of sample means you would get from this population when you collect a sample of this same sample size. In green, we've labeled each of these vertical lines with the t-score, otherwise known as the standardized statistic, the standard score. 0 is in the center. This is the sample statistic value that is 0 standard deviations away from the mean. 1, a standard statistic value of 1, a t-score equal to 1, means if you have a sample statistic of X bar equals 458, that is a sample statistic that is 1 standard deviation above the population mean. If you have a sample statistic, a sample mean of X bar equals 466, that is 2 standard deviations above the mean. It's a t-score equal to 2. Similarly, -1 matches up within X bar equals 442. 442 is a sample statistic that's 1 standard deviation below the mean, and 434 is 2 standard deviations below the mean. It is a t-score equal to -2. All right, now we have a distribution that's labeled with the values of the standardized statistics, and it's labeled with the values of the actual sample statistic X bars. Part C then says, identify the standard score of the given observed statistic. Our given observed statistic from the problem was 456.2. An X bar of 456.2 would be approximately here. It's between 450 and 458. So X bar equals 456.2 is approximately there. It is between t equals 0 and t equals 1. It's between 0 standard deviations above the mean and 1 standard deviation above the mean. And it looks like it's closer to 1 standard deviation above the mean. I would estimate t is about maybe 0.8. That's just an estimate. We can go ahead and find the actual value using our t-score formula. T-score is found by taking your observed statistic minus the mean of the distribution divided by the standard deviation of the distribution. So in this case, our observed statistic is 456.2 minus the mean of the distribution is 450, all divided by the standard deviation of the distribution, which is 8. The numerator is 6.2, and that's divided by 8. We get 0.775. So our t-score is 0.775, which again is approximately 0.8. So my estimate was pretty good. It's saying our observed statistic is 0.8 standard deviations above the mean of the distribution, above the population parameter.